7.6, solving quadratic trig equations. So we did solving linear trig equations, and when we solved linear trig equations, we knew to just bring the numbers over to one side and solve when we have a number on one side and a trig ratio on the other. And we got multiple solutions, maybe. Quadratics, we know quadratics have multiple solutions. They have multiple linear solutions. And if each linear solution has multiple trig solutions, then you can see where this is going, right? You break down the quadratic into multiple linear solutions, and each of those linear solutions could have multiple trig solutions. Okay, so you'll see firsthand. It's not an always thing, but sometimes. Okay, so we're just going to solve for solutions in all these questions, getting increasingly more difficult as usual. So we have an equation over here. I notice that this is a quadratic because of that square on the sign. So as soon as I notice it's a quadratic, I don't bring numbers over to one side. I have to bring everything over to the left or the right and have 0 on one side. Remember, solving quadratics, 0 has to be on one side because a quadratic is a multiple. And it's easy to figure out the solution when you're multiplying and a 0 is on one side. So I'm going to bring this 2 over this way. And I'm here. Now, it's common to get stuck here, but you're probably only going to get stuck here like the first time you see this. Solving trig is the same as solving regular quadratics, except instead of x, it's sine x. So if you envision this to be this, which is a very, very low-level grade 10 solving quadratics question, you should have no problem doing the one on top. So I'm going to do the green one. I need a 1 and a 2 to get this, no problem. I'm going to open up brackets. X goes here, 1, 2, signs are different, bigger one's there, done. Okay, so I just factored that x squared minus x minus 2, if you can relate that to this. Well, now instead of x, I have sine x. So this is what I really have. Okay, so nothing really serious, you know, I can use my calculator even to factor that. It's no big deal. And now I have to solve for both of these. So I have to say, well, I want to figure out when sine x plus 1 is equal to 0, but I also need to find out when sine x minus 2 is equal to 0. And these are my two linear solutions, and now I bring it back to 7.5, and I solve these. Okay, so the quadratic stuff, the 7.6 stuff is now done up here. So I bring that 1 over, and I say sine x is negative 1, and I bring that 2 over, and I say sine x is positive 2. If you know anything about sine in a unit circle, you know that this can never be true. The ratio of sine can never be greater than 1 because it's opposite over hypotenuse, and the hypotenuse is always greater. So I can never have a number greater than 1 when we're talking about sine. So this right here, not possible. I love getting solutions that are not possible because it reduces the amount of solutions that I'm going to have, right? I just saved possibly 1 or 2 solutions here. Awesome. Now I'm going to look over here. It's a 1. Oh, even better. I love when sine and cos are 1 because there's one solution. It's either vertical or horizontal. Well, this is sine is negative 1. That means it's 3 pi over 2 down here. So I know that x equals 3 pi over 2. And I'm done. I only have one solution. I got out easy in this question. Okay, so anytime I have a number greater than 1 and we're just talking about sine and cos, not possible. 10, you're allowed to have a ratio greater than 1. And anytime you have like a 1 or a negative 1, you should be able to solve that easily as well, especially in sine and cos, right? Sine is 1 here, cos is 1 here. Easy. Okay, next one. I'm already everything over to one side. I got to factor this. Maybe you do green. After you do 3 or 4 of them, you probably don't have to do this anymore. I could just start factoring from here. Just ignore the sign. As long as I'm in square, power of 1, power of 0 in descending order, should be fine. That's a 1 and a 2. That's a 1 and a 1. How do you get a 3 by adding? A 2 and a 1. So I go like this. And I know this is a 1 sine x, and this is a 2 sine x, just like it was a 1x and a 2x in grade 10 or 11 and 12 and everywhere. The 1s go here, they don't really matter because they're both ones. Signs are the same, amazing, and they're both negative. That's an easy one. And now I'm going to do the same thing. I'm going to say, well, sine x minus 1 must equal 0, and 2 sine x minus 1 must equal 0. And now I'm going to solve. Sine x is 1. 2 sine x is 1. So I'm at 2 points right here. No, these are not answers. I'm just boxing them because I want to ignore the rest of my work. I'm focusing right here. I got to figure out when sine x is 1. You should know this. Pi over 2. The ones are easy. So x here is pi over 2. And I am done that. Maybe I'll box in red for final answers. Okay, and when it equals 1 over 2, I can use my special triangle, or I can just draw a little picture. Well, if sine x is not 1, okay, I'm going to have multiple solutions. So I got to find out where these solutions are. Well, sine is positive. So these are my solutions. X is here, x is here. So I'm going to get one answer and pi minus that answer to find my second answer. Okay, you should know that x is pi over 6 using special triangles. Or you could just use your calculator. Second function sine 1 over 2. That's kind of a cheap way. You should know what the 1 over 2 is. So because I know it's pi over 6, I'm going to say x equals pi over 6 is one answer, for sure. And that's this one. Now I got to figure out this one. Well, that's just pi minus pi over 6. 5 pi over 6. And I'm done. So just take a look at how much more work is involved when I have something like this. When I have something that isn't 1, bam, answer. As soon as I have 2 answers, now I got to figure out which quadrants they're in. Now I got to do pi plus, pi minus, 2 pi minus, all that stuff, right? So way more work involved when I have a special angle or a regular angle that I just use my calculator to find the decimal for. Okay, moving on. You saw this in linear trig too. When you don't have the same ratio, you have to change something. Okay? You have to change something. So I have to change something in this equation to have everything the same. And I also have to change everything in this equation to have everything the same. All right? What can I change here? Should I bring a secant to a tan? Should I bring a tan to a secant? I don't know. I can look at my trig identities, have them next to me. Okay, anyone know what secant squared is equal to? I think someone asked me this last week. Yeah. So this is 1 plus tan squared x minus 3 plus tan x equals 0. So I have to be in the same ratio. Okay, and I still want to be in square, not square, and then who cares about the number? Okay, now I'm going to collect like terms. And I'm going to put my 2 tan squared x first. I'm going to follow it with my tan x. And then I'm going to use my 2 minus 3 is minus 1 for that. Okay, so just the 2 times 1 minus 3 is minus 1. I'm just skipping a step there. It's pretty easy math. And now I do the same thing I've been doing. I've got a factor. A 1 and a 2, a 1 and a 1. I got to get a 1. Yeah, I can subtract them. No problem. Open up brackets. I guess I'll keep it to green. And I'm going to have a tan x here and a 2 tan x here. They're both 1s. That's amazing. But the signs are different, so now I got to make sure I use the right signs. So when the signs are different, slow down, max effort here. Signs are different. The bigger pair is positive. That's a 2. That's a 1 if I multiply. Ignore the tan. 2 times 1, 1 times 1. This is bigger. This takes the plus sign. That's minus. Okay, or factor it in whatever way you need to factor it. So here I'm going to have tan x is negative 1 and tan x is a half. After I did a few, I'm already skipping this step where I have to move things over. Solving lines is easy, right? I can just jump into the answer, right? Bring the 1 over, divide by 2. That's not a big deal. Okay, if you have to show an extra step, show an extra step. When is tan negative 1? Well, tan is negative here. And it occurs when I have an angle of pi over 4, a related acute angle. Okay, when is sine and cos the same? Pi over 4. Okay, so I'm going to use pi minus over here and 2 pi. Let me write that here. This is pi minus pi over 4. And this is going to be 2 pi minus pi over 4. So my answer's here, pretty easy. 3 pi over 4. And x is 7 pi over 4. Done and done. That's just using one of them. Now I have to use the 1 over 2. Okay, if you don't remember, I can draw my special triangle maybe somewhere. Put my 2 over here, my 1 over here, my root 3 over here. This is my 90. This is larger, so this angle has to be pi over 3, and this has to be pi over 6. Okay, just a reminder, like you can always bring back your special triangle. Oh, sorry, I'm just going to use my calculator. Cool. 1 over 2. Well, hypotenuse never exists in tan, so don't get tricked by this being part of the special triangle. It's not. Right? This is opposite over adjacent. One of them's got to be root 3. So this is leading you to the special triangles, but it's not really there. Okay, so worst case scenario. Get your calculator. Make sure it's in radians mode. That's where the communication of that occurs in this question. And I'm going to say tan negative 1 of 0.5, and it's going to be 0.46. Tan is positive. And I got 0.46. So this is 0.46. This is 0.46. Now I know my solutions. One of my solutions is just 0.46. I'm done. And my other solution is pi plus 0.46. So as it's still written in my calculator, I'm just going to do plus pi. And I'm going to get 3.6. And I'm done. 4 solutions. Okay, be aware that eventually you could have, probably the highest is going to be 8 solutions. I actually have to write down, but that's like rare. Okay. 4 is pretty standard. You should be happy with 3 or 1. You should be ecstatic with 1 solution. All right, I don't think I have enough space for this one because it is the dirtiest one. Okay, so I got to change cos 2 theta into a version of sine. Okay, it's really difficult to change the power of 1 trig things, right? Double angles we can change into a square, and we need a square. And even squares we can change to other squares. So usually I leave the power of 1 alone. So I'm going to change this into the sine version. What's the sine version of cos 2 theta?
2 squared theta. Sine squared theta.
Done. Now I can distribute that 3. Maybe I'll show the work over here. So I distributed that 3 inside the brackets. Make sure that 6 is there. Be aware. Now I'm going to put it in descending order. While bringing that 2 over to join that 3 with subtraction. I never deal with negatives in front of my leading coefficients when I have a 0 on one side. So I'm going to change this. Okay, and now I'm set up. Okay, this was all just a setup to start. Get my green marker. A 1 and a 6, a 2 and a 3, a 1 and a 1. I have to subtract to get a 3. 3 and 2, nope. 6 and 1, nope. I'm done because they're both 1s. Cannot factor. Therefore, quadratic formula. Bring it back. If you can't factor, You still can solve. You just have to use the quadratic formula. Now, the quadratic formula, just like when we're factoring, this is just going to be like 6x squared minus 3x minus 1 equals 0. That's it, right? And then we just have to do a bunch of stuff like this once we get our answers. So negative b plus minus the root of b squared minus 4ac. I don't put the negative in here. I put the negative in front over here. However you want to do it, over 12. Sir, cool story. I'm definitely just using my calculator if I ever come up with the quadratic formula. And I'm going to say, like I always do, cool. So I'm going to have a 6, a negative 3, a negative 1. And my first solution is 0.73. And my second solution is negative 0.23. Okay, so do your thing, use your quadratic formula. I have these solutions, but it's not x, right? Because that's for this one. It's actually sine x. So I can just write it over here. Sine x is this. Draw a little diagram. It's positive, so I'm talking about this. Draw a little diagram. It's negative, so I'm talking about this. Quick little diagram just to see if you're adding or subtracting from pi or 2 pi. Now I got to find second function x equals second function sine of 0.73. And that's going to give me those x's. All right? Second function sine. I'm in the wrong mode. Second function sine of 0.73 is 0.82. Don't forget to round properly. It's 0.818, so 0.82. This is 0.82. This is 0.82. So finally, my solutions are 0.82. That's one of them over here. Bring this dotted line here. Okay, and pi minus that. So the answer is still showing in my calculator. I'm going to do pi minus answer equals 2.32. I'll stack it. And I found my solution for this quadrant. Move on to the negative version. All right, got to do the same thing. I'm not using that negative over here. I'm saying x equals sine negative 1 of 0.23. Sine negative 1.23 is oddly 0.23. So this is x, and this is 0.23. So my first solution is 2 pi minus 0.23 and pi plus 0.23. Okay, my calculator. Plus pi equals 3.37. And I'm going to do 2 pi minus 0.23 and 6.05. And I found all my solutions. You might be overwhelmed because there's like a lot happening here. And this is probably the most difficult section maybe in the textbook. And that's because it not only involves trig identities, which sometimes we struggle with. No, so I just struggle with like the process of solving trig identities. Okay, fine. But you have to use trig identities to replace trig ratios. Then you have to set yourself up like grade 10 factoring or quadratic formula. And then you bring back the chapter 6 trig, right? Solving for trig. You have to do it with one solution. You have to do it with the other solution. Just a lot of pieces of the puzzle, but everything is kind of easy. Nothing's really like deep thinking. All right, unless like there's some problem with this switch that you can't see. But those switches are usually pretty easy. And that's it, solving trig equations.